Hello, we are the Data Travelers, Antonio, Haley, Karen, and Bradley. The tool we chose to work with was MongoDB, and this presentation will introduce MongoDB and demonstrate some applications that can be paired with it. Objectives for this video are as follows. First, we will demonstrate MongoDB and Ruby on Rails along with a simple website demo. Next, we'll pair Mongo and Apache Spark. We'll show the installation, connecting the two together, and a little bit of data analysis with them, and then we'll close up with some final thoughts about the tools. The first task we did was to set up Ruby on Rails with MongoDB as its backend, and there are 4 mappers that can be used to map Mongo to Ruby. We ended up using Mongoid, the 4th one down there. And the reasons that we chose Mongoid were there's a lot of great documentation for it. There's an active community contributing to that documentation. It's compatible with other projects. It uses active validation, and it allows for caching, versioning, and timestamping. This image shows how Ruby and Mongo work together. So there's a one-to-one relationship between objects in Ruby and documents in Mongo. A document in Mongo is an object in Ruby, and this addresses the problem of impedance mismatch. Here is a simple website that we made using Ruby and Mongo. Each student is an object in Ruby, but is a document in MongoDB. So to create a new student, we simply have to add them. And there they are. And then now I exist there as a document in MongoDB. And we can also associate a paper with me, and that is automatically added to the document. So we don't have to create a schema or associate the document with me. It's just there as a part of the instance. And then if we go here, now I'm a part of this list. We can also filter on number of documents, and since I have 1, I will show up there.
And next, for the data analytics portion of this project, we decided to pair Mongo with Apache Spark. In summary, MongoDB is open source, NoSQL database. It's document oriented. It uses a flexible schema. You can use that schema or not. It stores data in BSON, which is binary JSON. MongoDB handles queries of documents. It's horizontally scalable. And Apache Spark can be described as also open source, fast computing. It's an analysis of semi-structured data, and it's an alternative to Hadoop or MapReduce, and they argue that it's faster for many tasks. It can work on top of a database. It interfaces with Python, Scala, Java, or R. And together these tools allow big data to be stored efficiently and analyzed quickly. And why did we choose these tools? Well, MongoDB documents can be easily modified. It doesn't require schema. No impedance mismatch between an object and a database document. It supports unstructured data, rich APIs, Ruby on Rails, Django, etc. With Apache Spark, we chose it because it is fast computation for large data sets. It sits between the database and the user, allowing access to data through multiple common languages such as Python, Scala, and Java. Supports more than just map and reduce functions, including queries and machine learning. And it's parallelizable for even faster computing, and variables can be made persistent. Together, these tools will let us store our data and streamline computation using memory efficiently in Spark.
To install these programs to our server, we're going to log in via SSH. And then once there, you need to know what version of Linux you're using. If you're unsure, you can use the cat tool to see which version you're using. So we're using Red Hat distro and CentOS 7.3. For installing MongoDB, there's a tutorial you can follow at this link, but it basically involves creating a local copy of MongoDB repository and then running the yum package installer. And on our system, it installed just fine. So once you do that, you can start the service with just sudo service mongod start. For Apache Spark, there are also online tutorials, so we've linked one here. Note that Apache Spark requires Java as well, so you'll have to install that. The way that we installed it was to download a tarball and unzip it, and then we had to set some variables, and then it was ready to go. But then to connect Apache and Mongo, we did need to install a connector, so that is available at the link included here. The dataset we've chosen just to demonstrate these tools came from a Coursera machine learning course, and it consists of city population and profits made by a food truck in that city in tens of thousands of dollars. And so then we're going to load that into MongoDB and use Apache Spark to analyze it. This is going to produce a linear regression model with stochastic gradient descent. And Antonio is going to explain a little bit more about that process.
Hello, this is Antonio. So I wanted to show our application for Apache Spark and MongoDB. First of all, I'm going to open the data set that we're going to be using. It's pretty simple. Just two features. One is a constant and a result. The number of samples that we have is 97. So now we use this command to import our data into the Mongo database. We're importing our data into the test database and into that collection named call. Now, this is the linear function that we're using to model our phenomenon. In this case, we're saying that it has two independent variables. We're actually only using one of those. And also it has a phi sub 0, which represents a constant. So in our application, x1 represents the tens of thousands of people that live in a city. And what we get out of the function is the profit that a business is getting out of that city. Now we're seeing the cost function. This is the function that we're trying to minimize in order to have our model approximate in the best possible way to the real phenomenon. The method that we use to achieve that is a stochastic gradient descent. So this is what a stochastic gradient descent does under the hood. Pretty much it keeps updating phi sub 0 and phi sub 1 in our case in order to minimize our cost function. Alright, so now we wanted to show the Python script that we used in order to train our linear regression model. We're using the MongoDB and Apache Spark connector and the machine learning library that Apache Spark provides. So what we're doing is pretty straightforward. We go and read the data out of MongoDB, then we get that data and provide it to the linear regression model, and we get finally the model coefficients back. Alright, so now we wanted to show the command that we're using to run the script. We have to give three arguments. The first two arguments tell Apache Spark where to hook with our MongoDB, and the last one tells what is the Spark connector that we're using. So we just gotta press enter, and Apache Spark does its magic. So at the end we get the weights, and that's what we can use for our model. So finally we wanted to show a plot of our data. The x-axis has the population of the city and the y-axis has the profit of the city. And finally we show how our model adapts to it.
This presentation was a brief introduction to pairing MongoDB with Ruby on Rails and Apache Spark to show the flexibility and the computation capability of these tools. Note that the dataset we used for the analytics portion was small considering what the tools can do together. Given what Mongo and Spark can accomplish when combined, some potential future projects could involve intaking and analyzing high-velocity varying data, for example, stock prices. It could involve the fast computation of large static data sets, data like a model of the city of Chicago bus ridership from data.gov. And also these tools offer the flexibility to add, remove, or modify fields as needed, which means they could easily be applied to a number of tasks.